Hi everyone, this is a recording of the GP4L demo for the automation and orchestration of Netbox with a booking system, Libre Booking, and some monitoring components such as Uptime Kuma and Oxidized. We will start first with the components of the system as a whole. So we use Netbox as the device inventory in which we store information about the devices. For each device, we have a minimum amount of information where we need to store information such as the device name, possibly site and location. If this makes sense to you, it will be replicated in the booking system. Every device has to be active in order to be monitored and managed in the booking system, and it has to have at least one management primary IP address. It can be version 4, it can be version 6. There are some specific tags for each device that are used by the rest of the system. The first two tags that you see here and start with Oxidized are used for the configuration backup configured with Oxidized, and they tell the system what is the model of the device and in which group the device belongs to, in this case, wedge PF132X. And the last tag, reg reservation, is used by the booking system. It tells the system that this resource can be booked via the booking system. So if you want to have a resource replicated in the booking system, you have to have this tag added to the resource. The way the changes that are made in Netbox are propagated to the rest of the components is via an orchestrator. We use the Camunda orchestrator for this, and Camunda reacts to the changes done in Netbox by listening to specific webhooks that need to be defined inside the Netbox in order for Camunda to listen to them. This is an example of how Netbox is configured so that Camunda can listen to the specific events via the webhook. This is the webhook and the address for Camunda where the process is notified, and then orchestration of the rest of the components begin. And in this part here are the rules that define what are the events that we listen to. So basically we listen to all of the events that are connected with updating information about the device, including deleting a device. And we specifically listen for the event of deleting an IP address. This second one is added because there are some problems when we only listen to updates of devices. If an IP address is deleted, the event that is notified to Camunda is not fully correct because there are still some bugs in the workings of the event rules of Netbox. So this is how we manage to go around these small bugs inside the system. So any change you make to the devices here is automatically captured by Camunda and then transferred to the rest of the components. What are the rest of the components? We have Uptime Kuma for monitoring of the devices, and if a device is active and he has a primary IP address, then a ping monitor is created inside Uptime Kuma, and this device is monitored. As you can see at the moment, there are two active monitors for GP4L Amsterdam and GP4L Paris, and one which is currently paused for Poznan. Why? Because the Poznan device is currently offline. You see here 4 devices, but the Frankfurt device is currently offline, and this is a newly created device by me. It has never been active in the system, and that's why it is not shown inside Uptime Kuma. You see only 3 there. It's the same with Oxidized. So you see the two active devices here that are inside Netbox, and Oxidized regularly takes a configuration backup out of these 2 devices. The other 2, which are offline, are not shown inside Oxidized. For the booking system, as I already mentioned, we are using Libre Booking. The way the system works is that in the beginning, during setup, we create some custom attributes inside Libre Booking automatically. These attributes are used for two purposes. The first one is an additional attribute about the user. So when a user self-registers on the booking system, he needs to supply information such as username, email, name, organization, and similar. The additional information that we require to be added is the so-called bastion info, where the user is supposed to paste his public SSH key. This public SSH key is then used when the reservation made is activated so that the user can get access to the Bastion machine, and through this machine to the devices and resources that he reserved using this booking system. The other custom attributes are related to resource. We have two custom attributes here. One is the netbox ID, so that we can have a singular reference and relationship between resources in booking and devices in netbox. And the other one is resource type, which can be at the moment GP4L devices or other. And this is just in case you're using the booking system, not just for booking devices which are known from netbox, but also other resources. And when you see the list of all resources, you would like to filter according to the type of a device. It's not an essential field, but it's a nice to have feature. As you can see in the moment in the resources list, there are 3 resources: the Amsterdam, Paris, and Poznan node. The first 2 are available for a booking by regular users, while the last one is unavailable because, if you remember, in netbox at the moment the Poznan device is offline, and that's why it's not available for booking. Inside the booking system, we replicate the information about the location taken from netbox. So that's why you see Amsterdam here, Paris here, and Poznan here. And when we create the device, the resource in booking, we also define a couple of rules for its use. For an example, all reservations concerning resources that are taken from netbox must be approved by the admin, and permission is not automatically granted, and the use of the booking reservation requires check-in and check-out by the user. What we also define is the duration of the reservations, that the reservation must last at least 1 hour. It cannot last more than 90 days, and it can be made across days. Another thing that is done during the setup of each of the resources is this permissions part, where we allow access for the resource to be booked and to be managed to a special group of users, which is called GP4L users. These are all the users that self-register on the booking system. So in this way, every time a device is added inside netbox via Camunda, the device will also be added as a resource inside booking. All of the information from netbox will be replicated, and the rules regarding access, duration, and permission will be defined as per configuration. Of course, all of these things, such as the name GP4L device, the minimum reservation time, the maximum reservation time, and the name of the group, and so on, are configurable parameters at the beginning when setting up the scenario. So you can configure Camunda with different values and with different names for the group, for the type, and so on and so forth. So basically, every change that I'm going to do in netbox is going to be translated into these other 3 components, and then you can monitor the devices, you can get the configuration backup for them, or you can use the devices as resources for someone to make a booking reservation. I will show you now an example. For an example, this new device that I created, but it has never been active. If I change its state to an active state, then this is going to be propagated to the rest of the components. So all I have to do is save this change, for the device to become active. And then if I go to Uptime Kuma, then this device is going to show up. Here it is. And then the ping monitor is going to start to work because I haven't supplied an active IP address. This one is not reachable, and that's why we have that the status of the monitoring probe is currently down. The same happens in oxidized. So if I refresh the view of oxidized, you will see 503 service temporarily unavailable, because what happens in the background is that oxidized is connected to a GitHub repo. We update the information inside the GitHub repo, and when the nmas container sees that the GitHub repo has been changed, it has to restart. So that's why it takes a little bit of time for the container to restart, and then you can see the new information inside the system. If we now refresh the page, we will see that Oxidize has been restarted, and here is the new device that we added. Now, if we go to the booking system, refresh the page here as well, we will also see that a new resource has been added. It's here, the Frankfurt resource. It has no location because I didn't set any location inside Netbox, so there is no information to provide in here. The same thing happens if I do something else inside Netbox. For an example, let's, I don't know, rename the device, give it a new name, and save the changes. Then these changes are going to be propagated across the rest of the components. So we will see a renamed monitor here. And similarly, you will see a change inside Oxidize. Here it is, the renamed device. And of course, if we go to booking and refresh, we have the renamed device here as well. Similarly, it reacts to, I don't know, a deletion of IP address or a change to the status. So here I will take the one in Paris and I will make it offline. And then this is going to be propagated to the rest of the components. So this is why the probe is now paused. And the same thing happens with oxidized as well. So if we go here, the device is no longer in the list because it has been taken offline. When you go to the booking system, then the device that was taken offline is having a status unavailable. When you have a status unavailable, then a regular user inside the system cannot create a reservation with this resource. Let's now try to log out from here and log in as a regular user, just to show you how it looks like, the whole procedure of reserving resources that have been created using this synchronization with Netbox. Now I am a regular user. I went through a procedure of self-registration and I created an account here. Unfortunately, I cannot show you the self-registration part because the account is already created and I cannot create a new account with the same email address. As you can see, I already have one future reservation that is going to start on tomorrow, and it's going to last until Monday. And these are the resources that I have reserved during this time period. As you can notice here that the resource that we just renamed is also renamed here. So even if the resources are already in use by someone, their names are automatically changed inside the system. What we can do is create a new reservation. Let's use this new device that has no upcoming reservation in the next 30 days. So I need to create a new reservation. I can define the start and end time of this reservation. Let's say it starts from 8, but it's going to last for a couple of days. Let's say until Monday, until midnight. It doesn't repeat. It's going to be this resource. If I want, I can add multiple resources. And the resources that are not available because they are already booked by someone else are shown with this red color and crossed line, so that you know that it's not available and you cannot add it to your reservation. The user needs to supply a title for the reservation and a short description. These fields can be made mandatory inside the system, or they can be made optional. This is part of the configuration of booking, and it can go either way. It depends on the admin. If you want, you can also check these boxes here, and you will receive an email as a user with a reminder that the reservation is going to start in 15 minutes, or is going to end in 15 minutes. And you can add other users that are going to be using the same reservation at the same time. When you press create, you get this message where it says that one or more of the resources require approval before usage. So the reservation will be in status pending until it's approved. And that's why it has this yellow color here. So now when we sign out and we sign in as an admin, we can review the reservation. Here it is, experiment 1, and we can decide if we want to approve or reject it, or maybe update it, and then the user is going to be notified. Maybe you ask for more information and then you decide whether you want to approve or reject. Let's approve this reservation. So in the moment it is approved, the color is changed. The same change of color and of status is going to happen on the user, on the regular user account. And what happens in the background is that Libre Booking is talking to another orchestrator, and this time this is Airflow, where there is a process running. And for this process, scheduling is being made. This queue has become 2 because we now have 2 future reservations, the one reservation that we had before and one that we made now. This one, the old one, is starting tomorrow. This is the new one that is starting today in a while. And at the starting time of the reservation, this process is going to go to Libre Booking, get the public SSH key from the user database, and provides this SSH key to the Bastion key manager. This is the last component. This is the Bastion key manager, where inside this GUI you can take a look at what is the history of keys that have been provided to the key manager, what was the start and end time for the usage of every key, and who added the key. These are all keys that are sent from Airflow. So when the reservation time starts, then this key is going to appear here, because the process is going to activate, go and get the key and provide the key to the key manager. As end time for the key, the end time of the reservation from the booking system is going to be provided. The way the system is defined is that you can have multiple reservations starting at the same time. So if you want, you can even create another reservation that is going to start at the same time by the same or by another user. And this is not going to be a problem. You see now here I have the check-in button because it's 4 minutes to the beginning of the reservation, so I can check in, and checking in says, yes, I will really use this reservation. You can even configure the system so that the reservation is released if the user hasn't checked in the system during the first 10 minutes of the reservation. Let's say I do another reservation, a quick one that will start also from 8, and it will be 1 hour. This is just a quick one to show you that you can have multiple reservations at the same time. I need to first approve it so that it's active. So I'm going to log in as an admin, and I will approve this reservation. Once I approve it, Libre is going to talk to Airflow. This talking between Libre Booking and Airflow is done using a plugin of Libre Booking. which plugin actually acts like an event manager, similarly to the webhooks in Netbox. And with this, you can actually talk to Airflow and tell him to schedule yet another process. And as you see now, we have two processes with the exact same time start. Both of them are going to be executed in 3 minutes from now, and they will provide two keys for the key manager, each one with a different end time because of the different end times of the two reservations. While we are waiting for the 3 minutes to pass, what I can show you is the configuration page for the booking system. So the admin can change any setting here. It's no problem for the system. Everything is configurable, and as long as you don't touch things such as self-registration or authorization of reservations, then everything is fine and you can customize the system as much as you want. The only things that you need to make sure is that any updates of reservations also require approval, and you need to, of course, make sure that you always use this post-reservation plugin, the Airflow post-reservation, so that the booking system can talk to Airflow and the keys can be passed to the key manager. Anything else you change in here, like emails, I don't know, names, the layouts, and stuff like that, this is all up to you, and it's not going to make any problems for the workings of the automation and or the orchestration of the system. There are also some other features inside the booking system, such as reporting, managing the schedule of resources, and so on. You're also free to use this without any problems or breaking things among the other components. It's almost 8 o'clock, so we can go back to Airflow and see what's going to happen once the start time for the processes comes. Here it is. Now it is 8 and these two are no longer scheduled. The only one that is left is the one that is going to be executed tomorrow. So that means that both of the processes have been already executed. Just some final remarks before we close this demo. In addition to this live synchronization between Netbox and the booking system, there is also implemented a daily sync process that runs after midnight every day and checks the synchronization between the devices in Netbox and resources in Libre Booking that have a Netbox ID. And if there are any discrepancies in the information, then Netbox is, of course, used as a single source of truth. So all of the maybe manual changes that someone has done in the booking system unintentionally are changed back so that the information inside the booking system corresponds to the information that is inside Netbox. One final remark, if you are interested in using this system, you don't have to use all of the components. So for an example, you can only use Netbox and the booking system and the connection with Airflow and the key manager. You don't have to use Oxidized, or you don't have to use Uptime Kuma if you don't want to do it. Of course, the other way around also works. So you can use Netbox with Uptime Kuma only, or Netbox with Uptime Kuma and Oxidized without the booking system. So all of the components are separated between each other. I think we went through all of the main points of the implementation. So I thank you for your attention and I wish you a wonderful day.